Geology is a fascinating science. It is the study of our Earth. We learn about rocks and mountains. We study oceans and volcanoes. For a long time, geologists used tools like hammers and compasses. Now, amazing new tools are here. These new tools are changing everything. They help us see Earth in new ways. It is a very exciting time for geology. One of these super tools is machine learning. This sounds like something from a movie, but it is real and it is very smart. Machine learning means computers can learn. They learn from huge amounts of data, like numbers, pictures, and sensor readings. Computers find patterns in this data, patterns that our human eyes might miss. This helps us understand Earth better. It's like giving geologists superpowered brains. Another amazing tool is 3D mapping. Think about a regular map. It is flat, showing roads or rivers. Now imagine a map that shows depth, a map that goes down into the ground. That is what 3D mapping does. It creates digital models of Earth's layers. We can see what is hidden under our feet, like different types of rock, or where water might be flowing. These technologies are a big deal. Machine learning and 3D mapping work together. They help geologists learn so much more, and they help them learn it faster. We can explore places we never could before. We can understand complex Earth systems. This new understanding is very important. It helps us find resources responsibly, and it helps us protect our planet. This is just the beginning of the adventure. So, how do computers learn about rocks? It all starts with data. Lots of it. Geologists collect information about Earth. This can be the type of rock, or the chemicals found in the soil. It can be measurements from earthquakes, or even pictures taken by satellites. All this information is called data. Computers need this data to start learning. The more data, the smarter they can become. Once we have the data, computers get to work. Special programs called algorithms look at it. These algorithms are like instruction sets. They tell the computer how to find patterns. Imagine sorting a giant pile of beads by color, size, and shape. Machine learning algorithms do something similar, but with complex geological information. They find connections we might not see. This helps us understand Earth's history. Think of it like teaching a child. You show a child many pictures of dogs, big dogs, small dogs, fluffy dogs. Soon, the child learns to spot a dog. Machine learning is a bit like that. We feed the computer geological examples. For instance, data from known gold deposits. The computer learns what signals gold. Then it can look at new data and predict where more gold might be. This process is incredibly powerful for geology. Computers can analyze vast data sets quickly, much faster than any human could. They can spot subtle clues in the data. These clues might point to mineral deposits or indicate areas prone to landslides. They can even help predict volcanic eruptions. The computer learns Earth's secret language. It translates it for us to understand. This helps us make better decisions. Imagine you have a giant layer cake. You can see the frosting on top, but what about all the layers inside? Are there chocolate layers? Vanilla layers? How thick is each layer? Earth is like a giant, complex layer cake. We live on the very top surface, but geologists want to know what's beneath. 3D mapping helps us see inside. It's like getting a recipe for the Earth. These 3D maps are not made by digging. That would be impossible for deep layers. Instead, geologists use clever techniques. They use data from many different sources. One source is seismic surveys. These send sound waves into the ground. The waves bounce back differently from layers. This tells us about rock types and structures. We also drill boreholes sometimes. These bring up samples of rock from deep down. This data is then fed into powerful computers. The computers use special software. This software pieces all the clues together, like putting together a giant 3D puzzle. The result is a digital model of the subsurface. We can spin this model around. We can slice through it on the screen. We can see the different rock layers. We can see folds and faults in the rocks. It's a virtual journey to Earth's center. These 3D models are incredibly useful. They help us understand how mountains formed, or where oil and gas might be trapped. They can show pathways for groundwater. This is vital for finding drinking water. Engineers use these maps too. Before building tunnels or tall buildings, they need to know what the ground is like. 3D maps provide this critical information. They make the invisible visible. Some parts of our planet are very hard to study. Think about the deepest parts of the ocean. The pressure is immense and it's dark. Or think about the tops of high mountains. They can be covered in ice and dangerous. Vast deserts are also challenging, and so are dense remote jungles. Getting geologists to these places is tough. It can be risky and very expensive. But these places hold important clues. Luckily, technology gives us new ways to explore. Satellites orbit Earth constantly. They carry special sensors and cameras. These can see things we can't from the ground. They can measure tiny changes in land height, or detect different types of minerals. Drones are also becoming very useful. They can fly over dangerous terrain. They collect high-resolution images and data. These tools are our eyes in the sky. All the data from satellites and drones is valuable. It gets sent to computers for analysis. This is where machine learning shines. It can process these huge remote datasets. It can identify interesting geological features. For example, signs of ancient riverbeds or areas with unusual rock compositions. Then, 3D mapping techniques can be used to build models of these remote areas, even the parts hidden beneath the surface, so we can explore without physically going. This is called remote sensing. It allows us to map vast areas quickly. We can study places that were once mysteries. This helps us understand global geology, how continents move and oceans form. It helps us find resources in new places, and it helps monitor environmental changes, like melting glaciers or expanding deserts. Technology takes us where our feet cannot. Imagine having X-ray vision like a superhero. You could see right through walls or look underground to find lost things. Machine learning and three-dimensional mapping actually give geologists a kind of X-ray vision for the Earth. They help us find things hidden deep down, things like valuable minerals or sources of clean underground water. They can even reveal ancient buried landscapes like old river channels or volcanic systems. How does this X-ray vision work? Well, machine learning algorithms are key. They're trained on known geological data, for instance, data from areas with diamonds. The computer learns the signature of diamonds, and this signature includes many subtle clues like specific rock types found nearby, or tiny variations in Earth's magnetic field, or certain chemical elements in the soil. The machine finds these complex patterns. Once the computer learns these patterns, it can scan data from new, unexplored areas. It looks for those same subtle signatures, and if it finds them, it flags the location. This suggests there might be minerals there, or perhaps an underground water reservoir. Then, three-dimensional mapping comes into play. It takes all this data and predictions and builds a visual model of the subsurface. This model shows where to look closer. This technology is honestly a game changer for resources. It makes finding minerals more efficient, and it can reduce the need for expensive drilling. We can target exploration efforts better, which saves time and money. It also helps us understand Earth's history. Revealing buried volcanoes tells us about past activity, and finding ancient riverbeds shows climate change. It's not just about treasure, it's about knowledge. These tools unlock secrets buried for millennia. Sometimes when new technology arrives, people worry it might take away jobs. Will computers replace human geologists? The answer is a big resounding no. These amazing new tools are not replacements. They're helpers, partners, and assistants. They make geologists even better at their jobs, and honestly, they empower them with new abilities. Think of it like giving a chef better knives. The chef is still the expert. Geologists have incredible skills and knowledge. They spend years studying earth sciences, learning to identify rocks by touch, understanding how landscapes are formed, and interpreting complex field observations. A computer simply cannot replicate this experience, or the intuition a seasoned geologist has. Human brains are amazing at creative thinking and at solving unexpected problems in the field. These are things machines really struggle with. What these new tools do wonderfully is handle tasks that are hard for humans, like sifting through mountains of data or performing complex calculations very fast. Machine learning can spot tiny patterns across millions of data points. Three-dimensional mapping can visualize complex structures that are hard to imagine from numbers alone. This frees up geologists from tedious work and allows them to focus on bigger questions. So geologists become superpowered. They can use these tools to ask better questions, test their ideas more quickly, and interpret the computer's findings using their deep geological understanding. The technology provides insights, but the geologist decides what those insights mean and how to use them responsibly. It's a powerful combination, human expertise guiding smart technology. Even with amazing computers and satellites, old-fashioned fieldwork is still super important. This means geologists going out into nature with their rock hammers and notebooks. They walk the land and observe directly, climbing mountains and exploring valleys, collecting rock samples with their own hands. This is called boots-on-the-ground geology, and it provides information we just can't get any other way, not even with fancy tech. When a geologist is in the field, they use all their senses. They can see the subtle color variations in rocks, feel the texture of different minerals, and sometimes they can even smell certain elements like sulfur near a volcanic vent. They notice small details about how rock layers meet or how plants grow in certain soils. These observations are rich and complex. Computers might miss these subtle clues. This field knowledge is absolutely vital. It acts as a reality check for computer models. A computer might predict a certain rock type, but a geologist on site can confirm it. Or they might find something unexpected that the computer model didn't show. This helps to refine and improve the models, making them more accurate and reliable. Field data is also used to train machines. The better the training data, the smarter the artificial intelligence. So, it's a fantastic partnership. Data from satellites and sensors fills the cloud. Machine learning crunches these big data sets, and three-dimensional maps visualize the hidden underground. But it all connects back to real-world observations made by skilled human geologists in the field. The field data grounds the digital models, and the digital models help target fieldwork. It's a cycle of discovery and verification. This teamwork makes our understanding strong. We have explored some amazing advancements. Machine learning and three-dimensional mapping are truly cool. They are giving us new eyes to see our planet Earth in incredible detail, from high above in space to deep beneath our feet. This technological revolution in geology is opening up exciting new frontiers for discovery and understanding our world. It is a big step forward. These powerful new tools are not magic, though. They rely on the data we give them, and they rely on the questions we ask. Machine learning can find hidden patterns, but it doesn't understand what they mean. Three-dimensional maps can show us complex layers, but they don't tell us the whole story. That is where human geologists come in. Their expertise and experience are essential. They guide the technology and interpret results. The real power comes from combining these, fusing the new digital methods with the tried and true traditional approaches. Geologists use their field knowledge to validate what the computers suggest, and they use their intuition and experience to guide the exploration process. The computers handle the massive data and reveal possibilities humans might miss. It is a true partnership. This blend of old and new is the future. It allows us to learn about Earth more comprehensively and more efficiently. We can find resources more sustainably, better prepare for natural hazards like earthquakes and volcanic eruptions, and understand climate change impacts and how our planet is evolving. By working together, humans and machines will continue to unlock Earth's amazing secrets.